All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be starting a new course. This is a course by Google, I believe, and it is hosted on Kaggle. This is called the 5-Day AI Agents Intensive Course with Google. So, yeah, we are going to be learning all about AI agents. I'm super excited to get into this because ever since I'd heard about the concept of agents, sorry, give me a second. I have somebody else's stream running in the background just so I have some background noise. Yeah, okay. So, ever since I heard about the concept of AI agents, I've always been interested in learning more about it. Like from my point of view, AI agents were basically uh, individual standalone applications that were running models in various ways. But I'm pretty sure I'm pretty sure more sophisticated tech has been developed, or more sophisticated techniques have been developed to build and run AI agents than the simplistic method that I was thinking of earlier. So that's kind of why I want to explore this a lot more, just so we get to learn more, and hopefully I also get up to speed with at least this side of AI tech, because I'm lagging behind big time because I keep getting distracted with a bunch of different things. I need to sit down and like make a small list of stuff. I actually okay. I kind of do already have a small list that I focus on. By the way, today's layout is going to be a tiny bit different because my I have Ubuntu running on WSL, which is on my Windows machine from which I'm streaming right now. I use WSL to run Ubuntu, and once I launch the Ubuntu system in there, I usually SSH into one of my other machines and attach to a specific tmux session, and that's why you're able to see a screen in the bottom left usually. But today I'm having trouble getting that Ubuntu on WSL started up, which is why I decided to just leave the bottom left empty and not really have anything in there. Somewhere in the middle of the stream, if Ubuntu manages to start up, Ubuntu WSL specifically manages to start up properly, then I'll be able to show that on screen. Otherwise, I don't think we're going to have that for this stream, which is not a big deal because I think for this stream, the majority of what we're going to be doing is reading, because we are still being, introduced to this course. Um, but yeah, yeah. What else was I saying? Oh yeah, I was saying that I have like a list that I kind of okay. You know what? We can just a second here. Yeah. Okay. Courses to learn. Okay. Current focus. This is something that I usually have in another machine. No, in another mind map on another machine. But for now, on stream, I'll do it in this mind map, and then later on after stream, I'll transfer it from this mind map to the other mind map on the other machine. Okay, so our current focus has to be learn and explore FCNN, CNN, RNN, and transformers. Then just learn Kaggle, learn data science through Kaggle courses. So we already, a good ways into that. We need to continue doing that. We are currently in intermediate machine learning. So we need to continue doing that. Then, oh, give me a second here. Just a second. I'm trying as the stream is running. I'm actively trying to launch that Ubuntu session. This is my Windows machine, and my Windows machine is not doing all that well. It hasn't been doing well for a while, so I've just been trying to make things work. Which reminds me, so I got a hold of a very old laptop from a family member of mine, and I so on that laptop as well, there is pretty much a failing hard drive issue, and that made me wonder if there was any way that I could run an OS on the laptop without actually installing it on the hard drive. So, is there a way that I could just load an OS onto the. Wait, just a second. I just remembered that I need to have my chat open in on my phone. So I'm just opening that up right now. Okay. Okay, great. Right. What was I saying? Oh yeah, so I was wondering if there's a way to run an OS on a machine. Basically, what I was wondering is that if I could use a machine's resources without actually having to install something on that machine. Granted, there would be certain limitations, but like, is there a way that I could use the resources on that machine without actually having to install something and make something persist on the hard drive? Is there a way to do that? And it turns out there is a way. It's called, I believe, PXE boot. And through this tech, through this mechanism, we can load an OS onto the laptop or onto the hardware in general. It'll be loaded in the RAM and it'll be executing by the CPU and stuff. None of it ever touches the. I mean, you would have to configure the thing to never touch, but yeah, none of it would ever touch the hard drive. But it uses the CPU and the memory, and believe there's uh, I believe there's a way to get it to use the GPU as well. So you can use the hardware without actually having to install anything on there. The entire setup is going to be on a different machine, and you just connect both of these machines to the network. So you have the, let's call it the worker node, the compute node. This is the machine whose hard drive you no this is the machine whose hardware you want to use, but you don't want to install anything on there. And then you have another machine, we can call that the controller node, because I don't have any other proper terminology to use. In the controller node, you have to install a sort of manager application that manages this session. And there's a huge, like, sophisticated setup to go through, but you'd be doing all of this setup on that machine. And anytime you want to load something, anytime you want to load up the OS onto the compute node, it would be loaded through this machine across the network. And there's a similar thing that happens for hard drive access. I believe that's where you use network accessible storage or something like that. You set up essentially storage that can be accessed across the network, and that's what your compute node is going to be using. And this is a very interesting concept because this opens up a lot of possibilities for various things. Now, what I'm doing is not something new. I'm sure a lot of people have done it, which is why, there's already tech surrounding this. There's open source tech surrounding this. Um, what I'm doing is not something new, but it's definitely new for me. It's a very new field, a very new subject for me to be exploring. And if this works out, that would be huge. That would be huge for me because I've been trying to find various ways that I can get computing power without actually having to connect peripherals and connect um, and a display monitor and connect a hard drive without having to install stuff. Basically, just being able to plug stuff in and get extra computing power. Because I already have a couple of systems that can do the management part. I just need something that can give the extra computing power. And once I'm able to set this up, it's gonna be it's gonna be, dude. I'm excited. I'm excited to explore this. I'm sure there will be limitations to this system, but if I'm able to get extra computing power out of it, then I'm not complaining. Because, like, imagine having a whole other system's computing power available to you. You have everything, the CPU, the RAM, hopefully the GPU as well, all of it available. I could, for example, run an AI model. Like, let's say I wanted to run a TTS system. That machine could handle the entire TTS processing, the audio synthesis and all. It can all be handled on that machine, and then the output can be sent back here. Basically, the distributed system that I was planning on building earlier, I could accomplish that. Give me a second here. I just remembered something. Um, I just remembered something. I need to check and make sure that we don't have that issue. Yeah. Okay. I think I think we're good. Yep. I think we're good. Okay. You know what? Enough yapping. Oh, actually, tiny bit more yapping. Another thing I need to bring my focus onto is Nano, and in Nano, I want to do two things: live VFX and what do you call it? Game dev. Yeah. Let me also add here, use external components like Bevy ECS. Right. Okay. So these are things that I need to currently focus on. One more thing that I could probably add in here is finish learning Gemini Rust. Yeah. Okay. Now let's go back and back. What is all this? Oh, okay. Yeah, this is all the Kaggle course. Okay, cool. Great. So, Okay. Now, um, we can start reading this. Okay, so what is the I think we read this already in the previous stream, but we can read the thing again. Maybe we don't need to read the whole, how the courses, how the course works and stuff. We can just read the intro and then we can jump to this. Okay, welcome to our 5-day AI Agents Intensive course with Google. What is the 5-day AI Agents Intensive? This 5-day online course was crafted by Google's ML researchers and engineers to help develop, explore, and wait, what? To help developers explore the foundations and practical applications of AI agents. Okay, you learn the core components, models, tools, orchestration, memory, and evaluation. Finally, you'll discover how agents move beyond LLM prototypes and become production ready systems. Okay? Each day blends conceptual deep dives with hands on examples. No, with hands on examples, code labs, and live discussions. By the end, you'll be ready to build, evaluate, and deploy agents that solve real world problems. Now, okay, here is a small complication that arises in this. It's that we need to watch this video that is going through concepts. Like for each day, there's a live stream, and I don't know if it is absolutely necessary to go through the entire live stream. Yeah. I'm also not entirely sure if I'm allowed to play the video on my own live stream, especially considering the fact that I'm going to then be uploading this VOD back to YouTube. I say back to YouTube because the live stream we're going to be playing is from YouTube. So I don't know if we are allowed. So I don't know if I should be watching the video on stream. So I need to find a way to like do that specific part off stream and then do the remaining of it on stream. Something else I noticed is that okay, so in this introduction course, which is the day one thing, they have this white paper. If you look at day one here, okay, they have mentioned. Wait, is this day one? No, this is day one. Oh, you know what? Maybe I should read this first. Okay, so in day one, they mention to listen to the summary podcast episode for this unit created by Notebook LM. And then to complement the podcast, read the introduction to agents white paper. And then complete these code labs on Kaggle, which build your first agent using Gemini and ADK. What is ADK? Agent Development Kit. Okay, that's interesting. I didn't know this was a thing. Hell yeah. So this is what I was talking about. That okay, I'm pretty sure that the tech has evolved and become a lot more sophisticated now, which to be fair, it might have been this sophisticated even back when I had first heard about the concept of agents, but like I never really took the time to explore the concept of agents. And so it, my simplistic thinking just imagined that, oh, agents are just standalone programs and there isn't necessarily like a sophisticated framework that enables, specific agent like behavior. That's also a possibility. But okay, uh, day one, introduction to agents. Today's white paper introduces AI agents. It presents a taxonomy of agent capabilities, emphasizes the need for an agent ops dis- for an agent ops discipline, for reliability and governance and discusses the importance of agent interoperability and security through identity and constraint policies. In today's Code Labs, you'll be building your first AI agent and your first multi agent system using Agent Development Kit powered by Google, no, powered by Gemini, and giving it the ability to use Google search to answer questions with up to date information. In the second Code Lab, the focus will be on multi agent systems where you'll learn how to create teams of specialized agents and explore different architectural patterns. Okay, right. So it says here building your first agent, okay, then building multi-agent systems, and then we have this as well. Okay, cool. All right. Want to have an interactive conversation? Try adding the white papers to Notebook LM. Can I just do that? Like, actually, okay. So the thing is, I should probably do this off stream because, so here's the thing. It's probably a good idea to add this to Notebook LM because this is a very big document. How many pages is this? Hold on. It says here 54 pages. So just to give you an idea, let me just like start scrolling here. Actually, let me give us a little more real estate. Okay, there we go. Let me start scrolling here. This is still going. We are still like early on in it. We are still in like almost reaching page 20. Now we have crossed 20 and it's still going and still going and still going. So we are definitely going to have quite a bit of information to go through. So I don't entirely know if we need to read this whole thing or if actually I think Notebook LM, if I feed this PDF into Notebook LM, it would then be able to like summarize things for me. That being said, I probably also want to read the information here. Okay, you know what? We can just start reading. Actually, what is did we read this? I don't think we read this. Okay, I guess we can start by reading this. So, introduction to agents. Artificial intelligence is changing. For years, the focus has been on models that excel at passive, discrete tasks, answering a question, translating text, or generating an image from a prompt. This paradigm, while powerful, requires constant human direction for every step. We are now seeing a paradigm shift, moving from AI that just predicts or creates content to a new class of software. Give me a second, dude. I'm having trouble reading this. Where was I? Yeah, moving from AI that predicts or creates content to a new class of software capable of autonomous problem solving and task execution. Okay, this new frontier is built around AI agents. An agent words. An agent is not simply an AI model in a static workflow. I think that's what I was initially imagining with my like simplistic um, thinking. I'm not sure what word to use there. Anyways, yeah, an agent is not simply an AI model in a static workflow. It's a complete application, making plans, and taking actions to achieve goals. It combines a large language model, no, it combines a language model's ability to reason with the practical ability to act, allowing it to handle complex, multi step tasks that a model alone cannot. Okay, the critical capability is that agents can work on their own, figuring out the next steps. Give me a second here. Yeah, figuring out the next steps needed to reach a goal without a person guiding them at every turn. All right, and that's where our white paper comes in. So let's start reading. Okay, agents are the natural evolution of language models made useful in software. From words, dude, holy shit. From predictive AI to autonomous agents. My God, why is it so hard to read? Also, maybe I could zoom in a little bit. I think that would make it easier for me to read this. Give me a second here. Okay, that's zoomed in a bit. Oh, too much. I think that's. Wait, can I make this fit? Does this fit? No, it doesn't fit. Does this fit? No, I don't know if it fits. Just a second. I think yeah, I think I zoomed in a bit. I'm hoping. Okay. From predictive AI to autonomous agents. Artificial intelligence is changing. For years, the focus has been on models that accept. Didn't we just read this? Didn't we? Hold on. Didn't we just read this? Yeah, I think we did. Okay. And then this new frontier is built around AI agents. Yeah. Okay. Allowing so and so without without a person guiding them at every turn. This document is the first in five. This document is the first in a five-part series, acting as a formal guide for the developers, architects, and product leaders transitioning from proofs of concept to robust production-grade agentic systems. While building a simple prototype is straightforward, ensuring security, quality, and reliability is a significant challenge. This paper provides a comprehensive foundation, core anatomy, a taxonomy of capabilities, architectural design, and building for production. Okay, all right, so what is core anatomy? Destruction, not destruction, deconstructing an agent into its three essential components: the the reasoning models, the reasoning model, actionable tools, and the governing orchestration layer. Okay, a taxonomy of capabilities, classifying agents from simple, connected problem solvers to complex, collaborative, multi agent systems. Then, architectural design, diving into the principle, diving into the practical design considerations for each component, from model selection to tool implementation. Okay, then building for production, establishing the agent ops discipline needed to evaluate, debug, secure, and scale agentic systems from a single instance to a fleet with enterprise governance. Building on the previous agent's white paper and agent companion, this guide provide I never read those, so I hope I'm not going to need to read those to, make sense out of this. This guide provides the foundational concepts and strategic frameworks you will need to successfully build, deploy, and manage this new generation of intelligent applications which can reason, act, and observe to accomplish goals. Okay, words are insufficient to describe how humans interact with AI. We tend to anthropomorphize and use human terms like think and reason and know. We don't yet have words for know with semantic meaning versus know with high probability of maximizing a reward function. That makes sense, actually. Yeah, because the latter two, they are more for uh, like AI related tasks, AI related. They're more for models. Like when you talk about thinking, reasoning, and knowing and stuff, this is more like human concepts. But when you're talking about an AI model, knowing with semantic meaning, for example, knowing words and knowing the semantic meaning between those words that makes those words into like a sentence. Just this is my own example of it, and knowing with high probability of maximizing a reward function. So I'm guessing that is more of like knowing how to do something in a way that is that gives you the highest probability um, of success, or that gives you the highest probability of a high success rate. Okay, those are two different types of knowing, but the results are the same 99% of the time. Okay, introduction to AI agents. In the simplest terms, an AI agent can be defined as the combination of models, tools, and an orchestration layer and runtime services which use the LM in a loop to accomplish a goal. These four elements from the essential architecture form, not from, form the essential architecture of any autonomous system. Okay. The model. The core language model or foundational model that serves as the agent's central reasoning engine to process information, evaluate options, and make decisions. The type of model, general purpose, fine tuned, or multimodal, dictates the agent's cognitive capabilities. An agentic system is the ultimate curator of the input context window, the LM. What? No, hold on. An agentic system is the ultimate curator of the input context window, the LM. Maybe they mean of the LM. So if I'm looking at it in that way, then an agentic system is the ultimate curator of the input context window of the LM. I still don't I still don't get that, but okay. All right. Tools, the hands. These mechanisms connect the agent's reasoning to the outside world, enabling actions beyond text generation. They include API extensions, code functions, and data stores like databases or vector stores for accessing real time, factual information. An agentic system allows a LM to plan which tools to use, executes the tool, and puts the tool results into the input context window of the next LM call. Okay. The orchestration layer. Wait, so these are all individual language models, I'm guessing. Because it kind of seems like one thing is going to give instructions to the next thing, which will then process stuff and then give instructions to the next thing. I think so. It might be a little more sophisticated than that, but like, okay. The orchestration layer or the nervous system, the governing process that manages the agent's operational loop. It handles planning, memory, which is the state, and reasoning strategy execution. This layer uses prompting frameworks and reasoning techniques like chain of thought or react to break down complex goals into steps and decide when to think versus use a tool. This layer is also responsible for giving agents the memory to remember. All right. Deployment, the body and legs. While building an agent on a laptop is effective for prototyping, production deployment is what makes it a reliable and accessible service. This involves hosting the agent on a secure, scalable server and integrating it with essential production services for monitoring, logging, and management. Once deployed, the agent can be accessed by users through a graphical interface, or programmatically by other agents via an agent to agent API. Okay, at the end of the day, building a generative AI agent is a new way to develop solutions to solve tasks. The traditional developer acts as a bricklayer, precisely defining every logical step. The agent developer, in contrast, is more like a director. Instead of writing explicit code for every action, you set the scene, that is the guiding instructions and prompts, select the cast, which is the tools and APIs, and provide the necessary context, which is the data. Okay. Just a second here. Okay. What was I? Give me a second here. Hold on. Okay. Um, where was I? Yeah. The primary task becomes guiding this autonomous actor to deliver the intended performance. Okay, you'll quickly find that an LM's greatest strength, its incredible flexibility, is also your biggest headache. A large language model's capability, no, capacity. A large language model's capacity to do anything makes it difficult to compel it to do one specific thing reliably and perfectly. What we used to call prompt engineering and now call context engineering, I didn't know that, guides LMs to generate the desired output. For any single call to a LM, we input our instructions, facts, available tools to call, examples, session history, user profile, etc., filling the context window with just the right information to get the outputs we need. Agents are software which manage the inputs of LMs to get work done. Oh, so then they will do the context engineering. That's okay. Hold on, dude. Yeah, no, that helps. That definitely helps. No, that can definitely help. But I can also see why this kind of a system would probably need to be hosted on the cloud. I am curious if I can get away with doing this locally and to what extent I can get away with doing this locally. I still haven't taken the time to, do research on running some of the more lightweight models locally, some of the more lightweight language models locally. I still need to do that so I can get kind of an idea of how many of them I might be able to run on the same machine at once. Because, yeah, if it's a large language model, then usually I mean, you could get one to run, but then the others, that one alone tends to be heavy enough. So imagine if you need to have multiple. Though, okay, what if we have these models that are built specifically for this purpose and not meant for, a very general kind of conversation? What if they're built specifically for agentic purposes? Would that somehow make the model more lightweight? I wonder. Let's see what models are being suggested here, because a lot of these models, I'm guessing they're going to be, well, okay, so because they mentioned Google AI Studio, I'm guessing we're going to be connecting to AI Studio and running the model there through some API that they provide. Before I get into that, I need to, because I'm going to be doing this locally, I'm not going to be doing it through the Kaggle notebook. I'm going to read the Kaggle notebook, but I'm still going to be doing it like locally on my end. Because of that, I need to look into. So I've been trying to find better ways to store credentials for, I don't know, auth tokens and whatever, secrets, or whatever you want to call them. Basically, stuff that helps you log into something, stuff that helps you get authenticated, stuff that helps you use an API, which again, you are authenticating yourself in order to be able to use that API. Basically, credentials. I wanted to find a more streamlined way of storing credentials. Because, like, usually when I need to do this kind of thing, in the past for my own projects, I created my own sort of systems for that. Not like very highly complex systems, but even those simple systems that I made, I had to make them. And that was part of the issue. So I was like, yeah, sure, I could take the time to build it each and every time that I'm doing a project, but do I really want to do that? Like, wouldn't that time be better spent doing something else? So if I'm able to find a more streamlined way to do this, to get user input to save a token, for example, and then just have that be written somewhere. And then I can like read it from that quote unquote somewhere later on whenever need be. And I actually found I found a couple of options for that. One that I did like was, because like one of the options that was mentioned was something that I was kind of already using, maybe not exactly that way, but like it involved writing something to a file. And I was using that already, but I was wondering if there's a better, more sophisticated, maybe more secure approach. And it turns out there is. So apparently there's something called, actually it might be called something different on each OS, but the whole idea is that it's an encrypted storage vault for credentials. It's an encrypted credential storage vault. Um, Different OSs have their own different versions, and each of these different OSs handle or they have their own workflows, they have their own different ways of working, but the idea is basically that it's a system in which you can store some credentials and you can retrieve those credentials whenever you need. So this way you're not storing it in like a plain text file. You also don't need to worry about accidentally exposing something. You can store it securely through these functions. And there's another thing that I was exploring, which was being able to enter data without it actually appearing in the terminal. And I think Python gives you the ability to do that. It's something called getPass. I think it's part of Python's standard library. I still need to explore that a little more. But yeah, I need to look into getPass for being able to enter, credentials without them being shown, and more importantly, for the actual credential storage vault service. In my case, it's mainly going to be Linux, but like fortunately these libraries are usually cross-platform, so they handle this same service for Linux and Windows and even Mac OS. In my case, it's mostly going to be Linux, but it's good to know that there is something um, for the Windows side as well if I ever need it. But yeah, I need to explore that as well. That library is called, I believe, Keyring. The Python version of that is called Keyring. I need to look. I found something similar on the Rust side as well, because there are a couple of things I'm going to be doing on the Rust side as well, where I do want to be able to store credentials without having to uh, without having to constantly worry about accidentally exposing them somewhere. So this is actually a good method. I need to explore this a lot more. At some point in time, maybe I don't know if I want to do this on stream. Maybe I could do it on stream. I don't see an issue with doing it on stream, because if I am practicing how to use this library, it's not like I'm going to be entering actual credentials into it. At least on stream, when I'm testing it out, I'm not going to be entering actual credentials into it. So we should be fine. But yeah, I might do it on stream. I might explore it off stream. I don't know. But yeah, when I'm doing all of this agent stuff and other Kaggle stuff as well, anything that involves me having to enter some kind of auth token, because usually when you're interacting with these APIs, you have to generate an auth token, or they'll give you an API token of some sort, or an API key, or whatever they want to call it, and you have to save that. And then whenever you're making your API calls, usually you have to either initially provide that token, and then you can start your communication, or with each and every call you have to provide the token, like in the case of REST APIs, for example. But the good news is that often libraries will kind of simplify that process for you, because when you're using a library that, for example, interacts with the Twitch API, um, TwitchLib, for example, which is a C sharp library which interacts with the Twitch API, it makes it so you just have to call functions, and those functions will then handle all of the sophisticated working, all of the work that has to be done behind the scenes in order to form the requests to send, and then also to get back the data, get back the result from that request. And part of that is